Okay, so we're into net ionics today. This video is going to talk about net ionic equations. The part that's going to probably give you the hardest time is solubility because you had a hard time with it before. But in this video, we're going to address predicting products again, balancing the chemical equation again, solubility again, and once you do all that, now you can create a net ionic equation and a complete ionic equation, and not in that order. Complete goes first and then net. So the first thing that we're going to have to do is figure out what the products are. So this is a double replacement reaction. You know that because you have a compound plus a compound. So you're going to take your positive with your negative, and then your positive with your negative. So remember, we're going to take potassium with nitrate, and we're going to take lead with chlorine. So if you remember how to do this, remember we got charges attached to it. Potassium has a +1, -1, +2, -1. So all you do is you take your positive chlorine, your potassium, and you link it with nitrate. So you get NO3. Potassium with nitrate. It has a positive and a negative, so we have a positive and negative. Your other one, you're going to take, and remember we're predicting products, so we're taking our positive lead with our chlorine. So you have lead, which has a +2 charge, because remember what was up here comes down. So it had a +2 charge. Just so you know, this has a +1, -1, and that's why these dropped off. Okay. But we have a +2, and it's going to go with a chlorine, which has a -1. So this chlorine gets a 2, and remember these come off. Okay. So far, so good? Okay, so that's the first step, predicting the products. You're given the reactants, you predict the products. The next thing we have to do is we have to balance this equation. So, what we remember, if you remember correctly, what we used to do, or what we do is we see what's on the reactant side versus what's the product side. So those of you having trouble with balancing, here's some more balancing ideas. So you remember what I like to do is I put KCl, PB, and then because of this nitrate being exactly the same over here, I can put it in a box and keep my subscripts out there. So I'm going to keep that as one whole thing, nitrate. Now that only works if you have nitrate on one side and nitrate on the other side. So you start balancing it out. I have 1 KCl, or 1K, 1 Cl, 1 lead, and 2 nitrates on this side. On this side, on the product side, I have 1 potassium, I have 2 chlorines, 1 lead, and 1 nitrate because of that subscript right there. Okay? So now, I have to balance it out. And remember, I need to have, it doesn't matter what I start with, but I'll start with chlorine. On this chlorine, remember, I have to have something on the line that's going to multiply to the subscript that's there, which is a 1, to give me a 2. So I have a 2, which remember is going to distribute to each one. So chlorine has 2 and potassium has 2. Everything else stayed the same. So now, what do I need to change on this side? Well, if I look back at potassium, again, I have to have something on this line that's going to multiply to the subscript that's right here, that's a 1, to give me a 2. So if I put a 2 on the line, it distributes. So this becomes a 2, but this 2 multiplies to the subscript of 1, and we get a 2. I have 2, 2, 1, 2. So this is balanced. I have 2 potassium chlorides and 2 potassium nitrates, and 1 potassium nitrate and 1 lead nitrate and 1 lead chloride. So far, hopefully you guys are following me here pretty good. I'm going to go ahead and get rid of this because I don't need it anymore because I've got it balanced. Hopefully you guys can still see that it's a 1, 1, 2, 1 ratio. If you want to go ahead and add those in, go ahead and put those 1s in there. Okay? So, we've predicted the products, we've balanced the equation, now we have to check solubility. This goes back to your solubility rules. Hal hugs Aggies pretty badly. Okay? Seoul can bag hags pretty badly in Sri Lanka and Argentina. So those 5 rules that we had. Number 1, remember, says if it's with a alkali metal, then it is always going to be soluble. And if it's with ammonium, then NH4, it's going to be soluble, so it's going to be aqueous. If you have a nitrate, it's all nitrates, chlorates, perchlorates, and acetates are all soluble, no matter what they're with. They trump everything, remember? And then you have the halogens. Halogens are soluble unless they are with silver, mercury, and lead. And then you have the other ones, but that's all we're going to, you can go back and look at that. But let's look at this first one. I have potassium. Potassium is an alkali metal. It's also with a halogen. Halogens are soluble unless they're with one of the hugs Aggies pretty badly. It's not with either one of those, so this becomes aqueous. Okay? We have a nitrate. It is always soluble. So you have another aqueous. Okay? Then here's a nitrate again, always aqueous. Here is a chlorine. It's a halogen. It is soluble unless it's with silver, mercury, or lead. Well, in this case, it's with a lead. So we're going to make it a solid. Okay? Now, why is this important? The reason why this is important to know all your solubilities is because we're going to start doing a net ionic equation. A complete ionic equation is basically taking this information and breaking it down into its individual ions. And if you remember what an ion is, that means it has a charge. It's an atom or a group of atoms that have a charge. So what we're going to do is we're basically going to break this apart. Now, you only break apart anything that's aqueous. You do not break apart liquids or solids. They stay together because they are not going to create ions. But aqueous solutions or aqueous solutions will create ions. So what do we do to do a complete ionic equation? Well, I take each individual piece and I start working with it. So this first one here, I'm going to break it down into its ions. Now, because we distributed this 2, I have 2 potassiums. Each one of those has a positive charge, and it's aqueous. Then I have a chlorine. There's 2 of those, and it's aqueous, and it has a -1 charge. Remember, we're breaking apart anything that has an aqueous or aqueous symbol attached to it. We are not going to break down our liquids or our solids. So then the next thing I have here is a plus sign. Okay, so I'm just going to keep working with it. I have 1 lead, and it has a +2 charge because remember what's down here was originally up here. It's aqueous. Then we have, remember how I told you to keep it together? Well, remember this is an ion, NO3. Now, it has a -1 charge, okay, or a negative charge. But I have how many of those? I have 2 of those. So subscripts get added in, okay? So we put coefficients here because the coefficient went to both of them. I have to have 2 nitrates because it has 2 nitrates, okay? Then we put our arrow, and this should all be on one solid line. However, my board is teeny tiny. So we're going to move on to the next one, and I'll put it down here. So we're going to break this one apart because it's aqueous also. And remember, I forgot to put this as AQ. So anything that's aqueous gets broken into its individual ions. So I have potassium. I have 2 Ks, 2 potassiums, and they're aqueous. Because remember, it distributes. Then I have 2, because remember it distributed, 2 nitrates, NO3s, negatives. Okay? It's also aqueous. But now I have a plus sign, and then I have a solid. The solid does not break apart. Okay? This is supposed to be, like I said, it's supposed to be in a really long line. And this is your complete ionic equation. We broke it down into each individual ions. It tells you how many of each ion is in this equation. Now, here's where it's actually pretty fun, but it's different. We're going to do a net ionic equation. So what you're going to do with your net ionic equation is you are going to, I'm just looking to make sure I have it right here, cancel anything that is in the reactants and the products that are the same. They're like ions. So for instance, in this part up here, because these are my reactants and these are my products, okay, I have 2 potassium here, so they break apart into, they actually don't break apart, I'm sorry, they are what we call spectator ions. What is a spectator ion? A spectator ion is not involved in making the solid. So what we're doing with the net ionic equation is just basically describing which ions created a solid or a liquid. So here's another one. We have chlorine. Well, chlorine is in the solid, so it does not match. It does not look the same. It is not the same. Lead does not, it's over here in the solid, does not match. But here's 2 nitrates and here's 2 nitrates. So you break, that is a spectator ion, meaning it is not involved in the making of the solid. So what do we do from there? Well, that's our complete ionic equation. Then we look for the spectator ions and we cancel those out to make a net ionic equation. So anything you did not cross out, which is a spectator ion, you leave it off. The net ionic equation is whatever is left. So what is left? We're left with 2 chlorine ions, aqueous, plus 1 lead ion, aqueous, and it's going to yield lead 2 chloride, solid. And this right here is my net ionic equation. Okay, and that's what we're trying to get to. What was playing a part in the process when we did our chemical reactions? What was playing a part in making the solid? Well, these were the ions making the solid. Okay, so we predicted products, we bounced an equation, we checked for solubility because that's super important because we need to know what's aqueous and what's solid, what's liquid. We did a complete ionic equation by breaking each individual compound into its ions if they were aqueous. If it was solid or liquid, we left it alone. Net ionics is basically taking out all the spectators that were not playing a part and then rewriting what was left over that did play a part in the compound. Okay? So I'll see you guys back in the classroom.